This talk is about Koadic C3. As you can see up there is Command and Control by Zach and Sean. As you can tell, I'm new at this. These talks are being live streamed. Because of that, I would appreciate anybody who has a cell phone turning volume down so that we don't, in the middle of it, get a phone ring for everyone else to hear and harass you for the rest of existence, because it will be recorded as well. I'd like to thank our sponsors, VBScript, Productivity, Tenable, Amazon, and Source of Knowledge. It's their support along with the other sponsors, donors, and volunteers that make this event possible. And I want to thank you, all of you, for showing up, because if it wasn't for you, there'd be no one here to listen. With that, let's get started. I turn it over to Sean.
Okay. So on our agenda today, we're going to talk about some of the current open source malware options that you have during a penetration test. And then we're also going to be releasing a new tool today called Koadic C3. And it's an advanced rat made out of JScript and VBScript. And we're going to talk about some of the hell we went through with the Windows scripting quirks and stuff like that. And then we're going to have some demos at the end. So first of all, I'm ZeroSum. This is LFNot. And not with us today is Jenna Magius and Naders. But we're the red team at RiskSense. We worked on Eternal Blue, Extra Bacon, ported that stuff to Metasploit, did some of the original research on that kind of thing. So just a quick couple notes before we get started. You using this tool, you know we're not responsible for what you do. It contains a ton of overlapping research. So Windows Script Host has been around for 20 years or more. So there's a lot of things that are already well known about using the script host. But we did advance the state of the art a little bit, and we'll talk about that. And what we're releasing today is just a prototype. We've used it on real engagements, but there are a few bugs. So submit fixes, not tixes. And just to be very clear, we're talking strictly post-exploitation, so this assumes that you already have a shell in a box. You want to do something interesting with that shell. You want to move around the network. You want to privilege escalate, that kind of thing. So the current state of Windows post-exploitation, you have Meterpreter, Cobalt Strike, PowerShell Empire, pretty much a standard toolkit. Or you can roll your own. It's not that hard, but most people just use the normal tools. So we'll talk about some of the downsides of PE malware. So that's portable executables. That's Meterpreter, Cobalt Strike, that kind of thing. In a post-exploitation setting, most of the time you're going to be dropping a binary on the file system. And that's exactly what AV loves to eat up. Especially PSExec actually does drop a binary on the disk. So that is one area. So what you normally do to get around that is you use veil evasion or shelter or some type of cryptor or packer to evade the payload from AV. So that's one of the downsides, is that in a post-exploitation setting, PE malware is not a good choice. There are downsides to PowerShell Empire. So it officially requires Server 2008 Service Pack 2. You can get it working on earlier versions, but you also need a more modern version of .NET for many of the features in PowerShell Empire. And another really bad thing about PowerShell is that a lot of the things you're doing in PowerShell are getting logged. And I have right here a screenshot of the Windows Event Viewer logs, and you can see Windows PowerShell is a first-class citizen in the logs. And then right there is one of the error messages you'll get if you try running PowerShell Empire and you don't have the proper .NET version. So it was kind of out of that frustration for me that I embarked on this project last October. I wanted to look at, I was pen testing and I got on a box and the wrong version of .NET was installed. I was not able to run Empire. So I started looking at JScript and VBScript, researching that pretty deeply. So one nice thing about that is that it works on Windows 2000 Service Pack 0, possibly earlier versions of NT. I haven't tested it, but it is directly baked into Windows. It's not an add-on like PowerShell was kind of bolted on later. So it was much easier for them to log and things like that. So you get access to all of the COM objects that expose a prog ID. And we'll talk a little bit about that in a second. But there are ways to execute completely in memory, so you don't have to drop a file to disk to get a script to run. And that's one of the main benefits of Empire. There are downsides to the Windows script host, which is JScript and VBScript. You don't get access to the Windows API at all, traditionally. So that's a really bad downside. We'll talk about how we kind of worked around that. There's no threading model, so when you have an agent in Empire, you're running lots of jobs on it. And so it's nice to have all that threaded, so if one job's hanging, you can still do other things with that. You're missing a lot of the standard functions you'd expect in a programming language, such as base64 encoding. You can do it with certutil and some other binaries that are in the system folder, but they're not on all versions of Windows. And then one of the biggest problems is that all strings in JScript are wide Unicode strings, which means that a null byte is inserted. If you have a shellcode string, you have null bytes inserted between every character. So it's really bad for making structs or shellcode. So COM was kind of introduced as a way to write a class in one language and have it be able to be instantiated in another language. So what you would do is write a C binary that would expose a COM object, and then you can play with it in VBScript and JScript and stuff like that. And it's an arguable precursor to .NET. It has some slightly different goals, but it's still relevant, and it's found everywhere in Windows. And it's also distributed, so that helps with lateral movement and things. So this is an example of instantiating a COM object in JScript. This is the HTML file COM object, and actually from there we're able to get the clipboard data out of that COM object. So you don't have access to Windows API, but you have access to all the interfaces that these COM objects are exposing. And so that's what we kind of explored, is what with this attack surface can we do with all these COM objects? We originally started the project in VBScript, but we quickly abandoned it. If you've never played with it, it's really messy language. If you come from a C-type language, it's not fun to work with. It has a weird exception handling method, so instead of try-catch blocks that you get in JavaScript, you have to do on-error resume next for every scope, and then every line of code you have to check for if an error condition was set. And then there was also Schlemel the painter problem, which is a thing with string indexing. So if you have a string, what you really want is O of 1 lookups. So if you want to go iterate over that string, you want every lookup to be O of 1. But what you get is every time you want to index into a string, you have to count from the beginning. So you get O of n factorial to traverse the entire string. So we originally found out a way to get past that. Every 1,000 iterations, we moved the start of the string pointer up. But eventually we just moved on to JScript, which does have proper string indexing. During the course of developing this tool, we researched Readline, which is kind of the interactive shell on Linux and Unix systems. And so normally, and right here we have a screenshot of Meterpreter. And as you're trying to use it, or you're trying to use Metasploit and Meterpreter shells are raining in, it's overriding your input field, so you see it's kind of staggered. So we figured out a way to redraw the shell every time a new shell comes in and still have your output not. And we committed that to Metasploit in PR 7570. It's still an issue in Empire. Metasploit actually has that commented out for now because there are some issues because they support Windows, which does not have Readline, and it was kind of messing with that. So they might revisit it. But our shell does fix that issue. I'll just talk about some of the Koadic terminology before we get into the kind of the architecture of it. So a zombie is what we are calling an agent or a session, as it would be called in Metasploit. A stager is a web server that we're spawning that is the C3 server. An implant is just a plugin that you can run on one of your hook zombies, and a job is an implant just starts one or many jobs on a zombie. So we have a plugin architecture. We have a load method for all plugins where you can register your variables. And then we just do a straight string replace of tilde and then the variable name. And then we have a run method, which for stagers, it'll spawn an HTTP server, and an implant will start a job. The job class is you start many jobs, and those report back. So we have a report handler. And then we also have a standard lib.js, which we added a lot of helper functions that will, so you can run commands on the system, upload, download files, and also perform all those HTTP operations. It's just an easier interface than working directly with the COM objects. We have all the traditional implant categories you would expect, so you can pivot, move laterally across the network, you can persist. Manage and utils are kind of like running commands or uploading files. Elevate, so we have a number of UAC bypasses. That's the run as administrator prompt on Windows. We have gather, so that would be things like dumping the SAM hive or scraping the clipboard. We have a scanner, so you can actually do a little bit of recon. You can do a TCP scan through COM. We have the fun stuff, so Empire, it'll play Thunderstruck, it'll max volume and play Thunderstruck. We have Cranberries zombie song. And then inject is all of the ways that we figured out how we could get access to Windows API, and then from there we run either Mimikatz or shellcode. So the stager architecture, generally to hook something with a post-exploitation context like Empire, you would run a manual command. You can also fish somebody in IE, and then if they say, yes, I want to run these ActiveX objects, you can actually hook them that way, Office macros, that kind of thing. We're just using the simple baked-in Python HTTPS threaded server. So you do get an encryption through TLS or SSL for the C3 server, depending on if it's enabled on the target. So Windows 2000 Service Pack 0 does not have TLS enabled. What we do is long pull, so that's kind of the old school way of querying a web server before WebSockets, is you would just make a call to the server will hang for a while, and then when finally there's some work to be done, it'll reply. And so that's what we do, we just do a long pull. And then when the job is ready, we clone a new stager and a new job, and I'll explain that in a second. So we're able to long pull HTTP forever because we're calling into COM, and so COM is the one that's taking a long time to return. If you run too much JScript, even for just a few milliseconds, it's actually based on the amount of operations you're doing. In JScript, you'll get this script unresponsive prompt on your, it'll pop up on the desktop, and the user has to click yes or no in order for the script to continue. It'll actually hang. So that's why we fork on a regular basis. So this is kind of the way that we fork. The first time you call home, you don't have a session ID attached to your URL. So we assign a session ID, and then we fork to a special job called stage. And so then if you call home to the server with a session ID, but no job ID, you're in the stage part. So now you're long pulling to get a job. It's when you want to run something. And so when finally you have some work to be done, we'll fork a new stage so we don't have all that script execution, and then we'll fork the actual job that you want to run. So that's kind of our threading model, is we just fork a bunch of jobs. And then finally, if you call home with a session ID and a job ID, and these are all UUID4s, then we'll send a job payload, which is just straight JScript that will get evaled. And then, so that'll do work, and then use the APIs to report back home with whatever the output of that job was, and then that job will exit. So traditionally, we do have support for the file-based stager. So this involves dropping a malicious JScript or VBS file on the disk, and you can instantiate these with CScript or WScript. But it's pretty easy to disable the Windows script host, and some environments do that, and also AV, you're writing to disk. So there's a thing called HTML applications on Windows, and inside the System32 folder is an application called mshta.exe by standard. And so HTML applications are kind of based on Internet Explorer, except for they have a different kind of security zone sandboxing method that lets you get access to the registry, the file system, and a command shell. Because normally when you go to a website in Internet Explorer, you're not going to get access to any of that stuff. So the payload for this is really tiny. It's just mshta and then a URL. And so we've run into issues with SQL injection and things like that where we're able to run a command, but we have a very limited space to put characters in, so this has helped versus something like PowerShell Empire, which has just these huge stagers. And then, so this is going to pop up a window on the desktop when you run an HTML application. So we experimented with many techniques to try and hide that window, and I spent a lot of time working on that. And eventually I just wrote some JScript that'll move the window off screen and resize it to 1 pixel. It'll blur to remove the focus, And then there's also some XML in there that will hide the window from the taskbar. But I thought this was like really bad, but I was looking at some malware samples that do the same thing, so I didn't feel so bad. So with run DLL32, that's just a standard application as well. And this lets you run an entry point inside of a DLL. There's ways to trick it into running JavaScript. So kind of at the bottom here, you're loading the mshtml.dll, and you're running run HTML application on it. And then that's getting the entire command line and evaluating that. And it starts with JavaScript. So now it's just going to start evaluating JavaScript. So we're kind of taking advantage of, I would say, buggy behavior in the way that that works. And this actually gives us less window visibility when we run it through run DLL32. So the MSHTA stager we actually have immediately forked to the run DLL32 version. It's a little bit longer of a payload to stage. And then the final stager we have is called regserver32. So this is what you would run to install COM objects and that kind of thing. And so SubT, this guy has been doing a lot of research on this topic for a while now. And he rediscovered that there was a behavior called COM scriptlets. So these are just kind of to help you install COM objects, but they run JScript. So it's less sandbox than MSHTA. So MSHTA is still kind of in like a weird Internet Explorer security zone, but regserver32 just doesn't have any of that sandboxing. So you can actually run as many instructions as you want with this kind of thing. It's not going to pop up a thing. But one thing I did find out is that it does write the file to disk, which is unfortunate. MSHTA is not present on Windows 2000, but this is. So you can stage with this on Windows 2000. So there's a couple ways to run commands from COM in the shell. So one is just the wscript.shell object. They have two methods available. One is exec and one is run. They're a little bit different. Exec lets you get access to standard out, but it's going to flash a little command prompt box, which is unfortunate when you're trying to stay hidden. So we actually use the run method, which we don't get access to standard out, but we kind of use this weird syntax at the bottom that just pipes standard error and standard out to a file that we put in temp, and then we just read that file. And so you can actually run those asynchronous commands, or you can wait and get the output. And then another way is WMI, which is the Windows Management Interface, I think. But that just lets you run Win32 process. So you can actually start other commands, but I don't believe you can get the output easily. So the way that we do it mostly or completely is with run. So one of the main things you want to do with a tool like this is you want to upload and download files. So uploading in this case is that we are writing from our C3 server to our zombie. So binary data is really hard to work with in JScript, and writing byte by byte, if you want to write to a file, it uses a lot of instructions. So there's a thing called ADODB stream, which I believe is some access database COM object or something like that. But it lets you write the HTTP response body, which is a stream object, directly to a file. The only problem is that you get an error like this, where it says safety settings on this computer prohibit accessing a data source on another domain. So that's part of the Internet Explorer sandboxing. So I wrote this code right here that just creates a temporary database in memory, writes to that database, selects from that database, and then now all of a sudden your stream is from not another domain and you're able to write directly to file. So just a quick workaround. Another thing that we had was downloading files. So this is where you want to get from the zombie. There's a file, interesting file on the zombie you want to pull back to the server. Through a lot of hard reverse engineering of it, we figured out that it was double encoding the post data, because that's how we're sending a file back, is we send an octet stream in the HTTP. So it's double encoding it with Windows 12.5.2, and then it's encoding that again with UTF-8. Another problem with sending post data is as soon as you send a null byte, it cuts off the HTTP request right there. So we just added another layer of encoding where we encoded backslashes twice, and then we added \OX30 for all null bytes. So we have to do 3 layers of decoding. It's really slow, especially if you use like the python.decode. So we added a hard-coded lookup table, and we were able to reduce the time it takes to decode by about 10 times. So it would take about a second per megabyte now, whereas before it would take 10 seconds per megabyte. So some of the UAC bypasses that we have in here are by Enigma OX3. He's another guy who's been doing a lot of research on this kind of thing. So these are current user hives. So any user can write to their own current user hive, and that's not a problem. And then Windows has these binaries in the System32 folder that auto-elevate to administrative rights. And then they're just searching these current user hives that you can write to from a medium integrity for a command to run, and then they just eval the command and run it. So I don't know why they do that. It's kind of insane. So they are kind of like cracking down on a couple of these. And in Redstone 3, they did fix a couple of them. But there's another project called UAC Me by HFirefox that has 35 plus methods. And some of those that we can do from this sandboxed COM environment. So one of the main things you want to do when you get on a machine is you want to, after you've elevated, you want to get the NTLM hashes off a machine. So Windows, and I believe XP at least has it, but I believe a service pack of Windows 2000 has a program called reg.exe, which just makes it really easy to dump these hives. So in order to crack or extract hashes, you're going to need the SAM system and security hives in order to decode and decrypt those. And once we have those, we're going to save those to disk, and then we're going to pull them back to the server, and we're going to run secretstump.py by core security packet. And it's the same thing for domain controllers, except for now, instead of getting the SAM hive, you're looking for the ntds.dit. So we're using volume shadow copies just to create a copy of the C drive and then pull the ntds.dit back. And then we also need the system hive, and then we run the same tool to extract the hashes from that. So there's several options we can choose to do our HTTP communications in COM. You'll notice that there are many different versions, but very similarly named. So this like XML HTTP and then server XML HTTP. So XML HTTP is kind of your original AJAX way ActiveX object to do web requests. And so this is going to be a very sandboxed COM object. Now server XML HTTP, this is what you would be running if you were running like a classic ASP web application. That'd be if you want to do a web request from the server. So you're going to have less sandboxing that way. And that's kind of like the cross-origin domain policy of browsers and things like that. It's kind of baked into these COM objects. So they all have basically the same interface, but a little bit different behavior, especially when it comes to security. So we take advantage of these to make a port scanner. So I found out about a thing called AJAX port scanning, so you can scan a local network using AJAX. So we use the server versions, and we are able to just scan, and depending on the error code, we can tell if a port is open or closed. So when you're scanning from this, you're on your zombies LAN. You're not on your original C3 box. So let's say you get a foothold past a firewall. Now you can scan that internal network for other boxes that might have 445 open, which is SB, so that you could pivot to. And then there's a WScript.network COM object, and this gives you printers and network shares that you are connected to on that zombie, so that can be helpful too. So PSExec is one of the main ways that you pivot in Windows environments. So this was originally a tool from sysinternals, and so it's a signed Microsoft binary now, and you don't even actually have to download this binary onto the zombie. You can just pull it off a share at sysinternals.com. When you do that, it does originate from the internet, so you get a dirty bit set, but the bypass was that we just execed it in a different way, so using WMI instead of VBScript.shell, and then we don't get the little dirty bit pop-up saying, are you sure you want to run this program? It didn't originate from this computer. And then you just run it like you would normally run it if you were a sysadmin doing things with PSExec. So the Metasploit PSExec is not this same binary. This is the official Microsoft one. It's not default, but yeah, like I said, you can pull it off the share that's on the internet. Another way you can laterally move is through WMI. So you can create this ActiveX object called wbemscripting.swbem locator, and then you can get to the root simv2 part of any hosts that you have a login for. And then you can set your impersonation levels and then spawn a Win32 process on there through WMI. So that's another way to laterally move. And then kind of just recently, or in January, Enigma OX3 found out about MMC20. So that's the Microsoft Management Console. It has an application, or it has a function called execute shell command, so you can actually execute a shell command on another computer. And then just this week, there was a lot of research going on Excel application and Outlook.application, and it is believed that these can be used for the same type of distributed COM lateral movement, so you can spawn these servers on another computer and then run functions on them, and then from there get a shell on another computer. So that's stuff that we don't actually have in the tool yet, but it's some future work that we're looking at. But we do have WMI and PSExec plugins. So now we're going to talk about kind of how we figured out how to fork to the Windows API and get access to that. So Work gave us Office licenses, and we didn't really use them very much until we had an idea to run shellcode through creating an invisible Excel COM object in memory, so it's not actually going to pop up a GUI. And then we're going to run Excel macros, which are Visual Basic, which is not Visual Basic script. You get full access to the Windows API. And then we also set some registry keys that will disable all of the little pop-ups that tell you to, are you sure you want to run, macros? So using that, we get access to the Windows API, and from there we're able to inject shellcode or reflective DLLs. Another thing that came out this year was .NET to JS by Tyrannito. He's at Project Zero. But basically this uses some of the COM objects that get installed with .NET, and they let you load a serialized .NET object into memory. And so from there, you're able to get access to the Windows API, because .NET has access to all the Windows API, or you can just run shellcode. Another free tool that we found is called Dynamic Wrapper X. So this was written in like 2000 by a guy named Yuri Popov and released as freeware. And this just is a COM object that you can register, and it lets you get access to Windows API directly from JScript. So SubT figured out that there's a process called registration for eCom, because normally when you want to register a new COM object in the system, you got to write a bunch of registry keys and write files on disk and all that. This, you can just drop this DLL, which actually comes back as 0 out of 61 on VirusTotal, in a manifest file, and then so you don't have to write all those registry keys, and then you can load this DLL and then you get access to Windows API. So once we got access to Windows API, we wanted to use the Mimikatz that's available in PowerShell Empire. That was kind of one of our design goals, is that we wanted to use that DLL because it's a known DLL. We don't have to recompile Mimikatz. We just want to use the one that they're using. The only problem is that the DLL mapping in PowerShell Empire is done from PowerShell. It's not an actual reflective DLL where the loader code is built into the DLL itself, written in C. It's written in PowerShell. So our limited instructions did not help for that, because actually loading a DLL is a lot of instructions that you need to run to parse all the PE headers and map it into memory correctly. So we weren't able to use that method. So I created a DLL called memishem.dll, which is a proper reflective DLL. And so all this is going to do is, well, first it's going to tell if you're on an x64 system and you're running an x86 process. So if you've ever run Mimikatz and you're in an x86 process on an x64 system, you're going to find that it's not going to work correctly. So we first determine if that's the case, and then we'll fork into an x64 process. Next, we're going to process hollow out notepad.exe from the sysnative folder, which is a fake little symlink in Windows that does get you to the proper system32 folder that you want, depending on the architecture. And then we're going to inject that powercats.dll into it. Then we're going to get the debug privilege, which is kind of like a God mode privilege on Windows. Then we're going to elevate our token to system, and then we're going to run whatever command that you entered as a plugin option. And now I'll let Matt run the demos.
Okay. So right now we're going to demo this up. I know everybody likes the demos. Nobody really likes to not have the demos. So we have a little environment set up right here. We have a domain controller and a small little domain. And what we're going to do is we're going to assume that we've gained compromise over at least one of the machines here. and we're going to introduce Koadic to everybody here. Okay, so now we're going to be using Python 2. So here it is. It just loads up just like this. You get a nice little help menu. You can get a lot of the different options and stuff like that. So we're going on. Just a minute. Okay. Fantastic. Just give me a second.
Our screen's messed up.
Yeah, our screen, I can't see it. I know you guys can. So, okay, here we go. So we're going to look at the info right here, and we're going to set the callback.
And normally this will determine what your outgoing IP to the internet is automatically, so you can leave it at 0.0.0, but we have a weird setup going on where we don't actually have internet. So he has to manually type his local IP.
Right, so it gives a nice little string right here. This is our payload that we're going to need to get on the compromised machine. So if you're on the machine right here, just lay it in, and I typed in the wrong one. Yeah. That's awesome. Oh, okay. Yeah. So. Just a second. We got a host-only network here. Okay, so let's do this again. So that's what's supposed to happen. So there we go. And you would just run that command, and no window would pop up, and then you can close this right here. And what we should see is we should see a zombie come in right here. So here we are with the zombies. And we get a little bit more information about the one that called back. We see right here that this was not an elevated command shell. So what we can do to kind of demonstrate the upload and download capability of this is we can use the implant to upload a file. So we set the local file.
What was the stage you're commanding? Was it
Yeah.
script or C script?
This one
It was
was
MSHTA. Uh-huh. Yeah.
Okay.
Yeah. So, yeah. All right. So we should. So as we see right here, we took the PuTTY file and we've uploaded it to the computer. There's been no windows or anything like that, and there's not much logs associated with any of this. And so just to prove that we're doing this correctly, we can take a SHA sum of the file we see here. It starts with 8.1. This is our SHA sum right here. And we're going to go back here, and we're going to use the implant to download the file again and make sure that the SHAs matches, right? So we put it into the temp. All right. Make sure we got the right zombie here. Oops. There we go. And then we got the file back here on the local machine. Download it to the temp directory. And we can make sure that they match, and indeed they do. So as we see, we didn't lose any information, and we got the proper upload and download functionality here. It's all over the Windows script engine. So that's all well and good, right? But if you want to laterally move and you need to elevate and stuff like that, it's kind of the idea of what we're trying to do here, right? So, so as we see, when we look at the zombies right here, the zombie that we got on this first machine, it's not elevated, right? So we're going to try to elevate through a little bit of a bypass here. So we're going to use an implant, and we're going to elevate ourselves, and we're going to use a little trick with the event viewer. Right? So we're going to set the payload to 0, and we're going to set the zombie to 0. I think we're on 0, right? Yeah, we are. And we're going to run. And if everything goes right, we should get a job back with an elevated UAC. Yep, and here it is right here. And you'll notice just like this little star is indicating it's an elevated privilege type of zombie that we have here. So we take a look, and indeed it is, right? So we can open up a command shell right here. You know, we give it a little bit of who am I? Look at groups. The screen's a little messed up because of the display here, but you'll notice that we are indeed using an elevated privilege right now. Yeah, here we are. Okay, so we can just exit into this. All right. So what we want to do is we have another machine over here, right? And we can see we can scan from this machine right here, just like we do in everything else. So we're going to use another implant, and we're going to scan. And we're going to go to an adjacent machine in the domain. And we see that it is open, right? So now we can know we can try to do some lateral movement to this machine. So we're going to use another implant right here, and we're going to I guess we should probably just dump the hashes of this machine first, right? So we're going to use the one that we were talking about on the slide, which is the dynamic wrapper X, right? And if everything goes right, we should get nice hashes right here. Here we go. I'm sure everybody's really familiar with this screen right here. Right? So we got these nice hashes.
That's the Mimikatz output that may have plain text passwords and also hashes of the machine.
Right. So now we're going to try to move on to the next machine here. Okay. Pivot. Assume we get that from the Mimikatz output right there. Usually do. So this is using the WMI to laterally move across the network right here. The font is a little funny here, yeah. Oh, I do. Thank you. Yeah. And here we go. And as you'll see, the one that we got back is also an elevated privilege. Right on here. And we have elevation. Open the what?
So you can see here he has multiple IPs because he's pivoted. So he has his first shell, which is the low privilege, medium integrity, and then the next one was where he elevated, and then the final one is where he's pivoted.
suit
And
here.
you can see he can run commands on the new box. I don't think it's going to leave that backslash.
Yeah, it's going to take a while too. So do we have any questions about any of this that's going on right here? Yeah.
So when you pivot it and fall back out to your main CNC, or you actually go through the established?
Yeah, it's going to tell the machine that has the. Okay, could you repeat the question a little louder? I don't think everybody heard you.
I'll repeat it. So he was asking if when the second machine calls home, if it's going to come back through the original box that we hooked first, or if it's just going to go straight to the server. It's going to go straight to the server. There's not really a lot of networking you can do inside of COM outside of HTTP requests, so we can't really tunnel things through, unfortunately. So.
Yeah, we also have things like grabbing the clipboard and so forth and so on. We can demonstrate later if anybody's interested. Yeah, you want to finish it up?
So we just want to talk quickly about some of the mitigations that you can do to stop an attack like this. So there are actually ransomware that are completely written in JScript now that do all of their crypto in JScript and can do a lot of these techniques. Nothing too sophisticated, but it might get that way, especially with the way that PowerShell is getting more and more sandboxed and stuff. So one thing that Microsoft has is the anti-malware scripting interface, AMSI. And so this was hooks that they added for antivirus that would allow them to get access to scripts before they execute. It was originally intended for PowerShell, but there is also JScript and VBScript support. So that is something that malware or anti-malware should look into. Another thing is device guard, app locker, CI. It's all kind of the same umbrella terminology for app whitelisting on Windows. It's a real pain in the ass to set up. You have to do a lot of registry and PowerShell and things like that to get it working. I'm hoping Microsoft will add a GUI or something eventually, but right now it's not fun to set up. But it's the best way to harden an environment, but not very practical really. But if you do get it working, you want to block the Windows script host, HTML application, COM scriptlets, and just whitelist the apps that you need and don't run anything else. Another mitigation is you can delete all of those EXEs that we're using for stagers. Windows Update will probably put them back. And another thing that I haven't tried that will probably break the system is you can delete a lot of those default COM objects, including the script parsers themselves. Those are COM objects, but there are components that rely on those, so you might break your system and have to reinstall. So one thing we want to do is add some of these ways that we've gotten into Windows API. We want to kind of have that added to Metasploit as just like a super module that just goes down the list of all the 3 ways that we have to get to Windows. And so then we can add that as a target for things like PSExec, which does have a PowerShell target, but it doesn't have a JScript target. We could add that. Some more future work. We need to explore COM some more. So a very large attack surface on Windows, underexplored. Probably more cool things that we can do. I don't like releasing dirty code, but some of the code's rushed. I'm kind of a perfectionist when it comes to code, so I'll probably be fixing up a few things at least. A little bit of a plugin revamp. There's a little bit of code reuse between plugins that I want to clean up. And then also I want to make jobs task-based. So if they're doing a lot of the common things, we can kind of not have to rewrite a lot of that code. Another thing I want to kind of add is a minimizer or an obfuscator for JScript that will just kind of change the payloads up a little bit, because right now they're all just the standard payload every time. We've kind of neglected persistence implants, which would be kind of cool to add. And then since we're using the basic Python HTTP server, we are vulnerable to denial of service and things like that. If you put your C3 on the internet, someone can come by and just totally open a bunch of connections and slow you down. So that's one thing that we want to kind of work on, is limiting, throttling the amount of IPs that can connect and stuff like that. If you're interested in knowing more about COM, the best talk I've seen on COM was this year by Tyranito, Project Zero, at Infiltrate 2017. It's called COM in 60 Seconds. It will tell you everything you need to know about the origins of COM, how it works, why it works. Kind of more to the point of JScript stuff. is a talk that was at BSides Nashville this year by SubT and Enigma OX3 called Windows Archaeology. A lot of overlap with our research. And then establishing a foothold with JavaScript by SubT last year at DerbyCon. He made a very basic JScript rat, so we kind of, as we were developing this, I saw that talk, and then just it kind of gave me the idea for Reg Server 32 and things like that. And so we put this code up on GitHub right now. It's at GitHub 0sum/Koadic. And we're also doing a workshop at DEF CON. It'll be a lot more C and shellcode and stuff like that, but we'll also have a GitHub up for that when that comes out. So be sure to check that out as well. And that's it for me and Zero Sum and L, if not, since there's any more questions.
Yeah. We have time for just a couple questions if anybody has any. Maybe one.
When utilizing TLS to hide your traffic, basically, is there a risk of people being, or defenders being able to track down the certs and then using that to figure out all the machines that you're on?
Yes. So you do need a valid certificate to do TLS communications because it's going to go through the normal Windows HTTP processes, which is going to check the cert store and see if this is validly signed for that domain. So yeah, that's one thing that will. I mean, it's pretty easy to get a TLS cert these days, but with Let's Encrypt and things like that. But it's one thing that can be tracked for sure.
Anybody else?
Have you guys used this on any engagements?
Yes.
So far, where like other stuff is getting caught, you had to sort of this.
Yeah, absolutely.
Yes. So he asked if we'd use this on engagements where other things have been getting caught. And yeah, I mean, we still run into, NT4 or Windows 2000 domain controllers and things like that. It does work on Windows 2000, at least the core does. A lot of plugins don't because Windows 2000 is very bare bones OS. Didn't really have a whole lot. But we have run into it, like I said before, with SQL injections where we needed really small payloads. And so it was one way that we could stage and just get a better shell. And then, it is kind of a niche thing. This isn't like our first choice. We'd rather use Meterpreter or something with, more direct capabilities. But it has come up and proved useful in a couple situations.
Especially on older, antiquated systems.
Yeah.
So like the main stager command, is it always the WSHTA?
No.
We got a couple.
Yeah. Okay.
So you see we have disk, MSHTA, Reg Server, and then run DLL32.
Okay.
So just different ways.
Those could be like smaller strings there.
Yeah, MSHTA is definitely the smallest string that you can do. Because it's just MSHTA and then your URL.
Okay.
So. All right.
Thank you guys very much.
Thank you very much.